In this lecture video, let's take a look at evaluating what is so-called radicals. So the entire module 15 is involving with this word called radicals. All right, so let's take a look at some terminology real quick. The radical, for most people or for most students, known as the square root. It's actually more than just a square root. We can have a cube root, we can have a fourth roots. Every time when we're talking about roots, okay, that is actually considered as radical. All right. So here are some of your quick example of radical signs. The number or whatever is inside the radical is called the word radicand. Okay, so the complete expression here offered by the textbook may be like a square root of 64. Okay, what's inside of it is called the radicand. So the whole entire square root of 64 is called the radical expression. All right. So if you have a graphing calculator, okay, most of the time the square root is right above x squared. So if we press second square root, okay, mine giving me a parenthesis, so where I can put my 64 in there. And of course, I get my answer positive 8. So for cube root or anything higher, we will need to press math. Number 4 right away is a cube root. Number 5, something called x root. So basically, you will use the x roots for anything higher than a cube root in the graphing calculator. So if your graphing calculator look a little bit different than mine, once you choose number 5, probably because well, let me erase that. Probably sometimes they will ask you to enter a particular number up here. You might have a little box where you can type in anything higher than a cube root here. So when we run into an example where I got to enter anything higher than a cube root, I will show you how to do that. So let me kind of explain a couple other things real quick before I go to this square root property. This is a very important concept when it comes to the next lecture video, how we actually evaluating square roots. This video, we're just going to simply enter these numbers in the calculator. So before we do that, let me kind of explain a couple of things. Why is square root of 64? Okay, why is square root of 64 is equal to 8? There is several ways to look at this. So I'm going to kind of explain one the very basic fundamental way. All right, 64 we know 64 is a perfect square number for 8. So I can actually write the 64, the radicand, as 8 squared. So since square and square root are like a opposite operation, just like opposite adding is subtracting, opposite multiplying is dividing. So square and square roots is considered, it's like an opposite operation. So technically they can cancel each other out. Cancel each other. So if I look at 64 as 8 square, square and square root will cancel out. So that means the only thing left with is simply just 8. Okay, this is one way we can think about why the answer is 8. Okay, so in the next video, when we begin to simplify our radical expression, oftenly I will actually say square and square root will cancel out. So the only thing left is whatever is inside of it. All right, this is called the principle of square root. Let's say a is a non-negative real number that's inside my radical. So the principal square root of a and negative square root of a is actually called the negative square root of a. So exactly what that means is this. It's kind of weird the way how they say it. Basically, if we have square root of 64. This 64, as you know, can now be written as square root of 8 squared. I can actually rewrite this 8 squared over the 64 as square root of negative 8 whole thing squared. So from our previous modules, especially when we talk about exponent rules, negative 8 whole thing squared, okay, raised into an even power. Negative number in the parentheses raised into an even power will always give me a positive answer, just like the 64 here being positive. So if we follow by what I mentioned here, square and square root cancels out, that means my answer can be an 8, or my answer can be a negative 8. Okay, so the principle of square root is basically saying if we can rewrite square root of 64 in two different ways, technically our answer is one is positive, one is negative. Okay, so a lot of times when you read the instruction for all these problems, they're constantly saying let's assume such and such is positive, because they really don't want us to write it as a negative whole thing squared. Okay, that's why they make they worded the instruction in a particular way. All right, so let's go ahead and evaluate our radical expressions. Express your answer as integer, simplified fractions, or a decimal number rounded to 2 decimal places. Like I mentioned before, we first talked about radical or square root back in module 6, but then in module 8 we also talked when we were classifying our numbers. Okay, we had something called rational numbers and irrational numbers, and a lot of examples that we did for irrational numbers are numbers that can never be converted back into a fraction. Rational means fraction. So the reason why it cannot be converted back into a fraction is because the decimal places. So if we take a look at this square root of 17 here, 17 is not a perfect square. So if I say second square root, put my 17 in there, it's going to give me some sort of decimal answer where the decimal places shows none of the repeating patterns. Okay, because if a decimal places show repeating pattern, those type of decimal number can be converted back into a fraction. So here, if I try to convert back into a fraction, it will never let me, because we consider these type of number as irrational number. So the problem wants me to simply round to 2 decimal places, which is 4.12. Okay, so for right now, that's the answer. But in the next video, when we begin to simplify our radical expression, we're going to run into a lot of numbers that is not perfect square, that is not perfect cubed. So what do we do with those numbers? Well, we're going to learn how to simplify, okay, those type of numbers. Rather than punch them in the calculator and have some sort of irrational number as for answer, we will actually express them with a radical. Okay, we will kind of express them a little bit differently. All right, for right now, we can just round 2 decimal places, but just understand we will quickly actually move away from the decimal answer, because there's really not much we can do with an irrational number for answers. All right, this is negative square root of 81. Most of y'all know square root of 81 is going to be positive 9. But then out here I have, but then in front of my square root, there's a negative 1 time. So my answer got to be negative 9. All right. So let's punch in a cube root. I'm going to use this particular example. By the way, if I do this problem by hand, I don't know if many of y'all remembered 125 can be rewritten as 5 to the 3rd power. So If we talk about using prime factorization that we introduced back in module 1, I can use a 5 going to 125 25 times. 5 can go into 25 again 5 times. 5 going to 5 is exactly 1 time. So this 125 is made out of 3 of these prime numbers. Okay, so that will be, so my 125 can be rewritten as 5 to the third. So cube and cube roots are like opposite operations, so they can cancel each other. So that will leave me with my answer simply going to be 5. Okay, so you might ask, well, Mr. Chen, why go through all this work just to come up with a 5 when we can put in the calculator? Well, because when this number is no longer perfectly cubed, then I will have to figure out a way to simplify my numbers and write my final answer as with a radical, not with a decimal. So in the next couple of videos, you will begin to notice why I go ahead and mention this now. But let me show you how to key it in the calculator as well. There are a couple of ways we can do this. If I go to math, I already got cube root number 4. So in the inside the parenthesis, I can type in 125, which is 5. So if I want to use this x root, okay, what I need to do first is enter my roots. Okay, the textbook called these roots. Sometimes the textbook called this root the index as well. So you type in the roots or the index, then go back to math, press number 5, and then I'm going to open myself a parenthesis and put in my 125 in the parenthesis. Then that will give me my same answer, 5. All right. Now, there was this rest of the instruction here is interesting. If the expression does not represent a real number, all these 3 number answer that we come up with actually exist on the number line. So what do we mean by not a real number? Not a real number simply means they do not exist on the real number line, on the actual number line. Because at the end of module 15, we will introduce something called the imaginary numbers. Okay? So it turns out, okay, this is kind of weird. We kind of wrap this back to what we talk about here. 256. Can't quite remember whose perfectly square is that. I know, let's try 16 squared. Oh yeah, 16 squared is 256. So let me explain why when you put this particular problem in the calculator, it's going to show something called not a real answer. So basically, my 256 can be rewritten as 16 squared. All right, this negative sign right in front of it representing -1 times. So I always ask students, exactly how many -1 do I have here? Do I have 1 of them or do I have 2 of them? Because if I really have two negative 1 here, maybe rewritten as -16 whole thing squared. Well, if this -1, okay, is being squared, raised into an even power, then this negative will actually become positive, because then that will be negative times negative, which is positive. So that means the negative sign will actually go away. So exactly how many -1 is here? Well, it's actually only 1 of them. Okay, so tell me, okay, square and square roots are opposite operation. And what we know about square is same number multiplied together. So what 2 same number multiplied together will give me -256. These 2 numbers got to be exactly the same. If you say 16 and 16, then that will be positive 256. If you say, oh, -16 times -16, that will be, again, positive 256. So what if you say, oh, 1 is positive, 1 is negative? Well, I just said these 2 numbers need to be the same in order to go back to the square part. This is no longer squared. Okay, so positive 16 and negative 16 will be negative 256. But what I'm asking is give me two numbers that are exactly the same. Multiplied together will give me negative 256. And you actually cannot give me one. Such thing does not exist. And that's the reason why, okay, that's the reason why negative, a negative, a negative sign, all right, cannot be inside of a even root. It can never be inside even root because it does not make sense. Because in order to have a positive a negative 256, okay, in order to have a negative 256, the 216 is actually not going to be squared anymore. One is actually going to be positive, one is actually going to be negative. Okay, so a single negative sign inside the even root can never actually give me a negative 256 because I actually cannot write them as something squared. Okay, that's any even roots. So that's the reason why when you actually type in square root of negative 256, it's going to say not real answers. So this problem is actually not a real number. Because such answer does not exist on the number line. Because you can never find two numbers that are exactly the same that will be negative. That will actually be a negative. Okay? Well, what about a cube root? Okay, let me write this problem down. A cube root of 8. The answer will be positive 2. Now, can a negative be inside the cube root? The answer is yes. Here's the reason why. The 8 can be rewritten as 2 to the third power. All right, so negative sign still in front of it. 8 is 2 to the third power. This negative is actually how many negative? One of them or three of them? Because think about this. This got to be a negative 8. So if you say there are 3 negative 2 multiplied together, then that will be negative 2, okay, whole thing to the third power, which will still be negative 8. So in reality, this negative sign in front of the 2 is actually 3 negative, because negative times negative is still going to give me what? That negative 8. Okay, so if you ever key in a negative sign inside of an odd root, the answer will be negative. So a negative can never actually be inside of an even root, but it can actually be inside of an odd root. Because now with the same negative 8, I can actually treat this negative 8 as negative 2 whole thing to the third power. Since cube and cube roots are opposite operation, they cancel each other out. So the only thing I got is negative 2. Okay, so negative sign can be inside an odd root, but not inside of an even root. Because you cannot rewrite this negative 256 as negative 16 whole thing squared, because technically that will make the negative sign become positive. So how do we actually have a negative 256 inside? All right, so just a quick lecture video on a quick introduction on the radical expression. All right, that will conclude this video. Thank you for watching.